All right, so now we're going to do the sum and difference in an angle formulas. What does that mean? Well, first of all, I want you to put it in this box right here. So we're going to say sum and difference, okay? But the idea is it's a sum or a difference within the angle. So this is what I mean. So let's say that we have sine of theta, right? And but here's what's going on. This angle here, theta, is actually a sum of two terms. So theta is equal to, let's say, like x minus 3 or let's say x plus 3. Let's do a sum first. X plus 3. So now what we have is we have sine of x plus 3. Now we've already discussed this idea of theta representing an expression, right? So now what we have here is, since it's sine of x plus 3, that x plus 3, that is an angle that is made up of a sum. Well, there actually is an identity formula that would allow you to convert this into something with a less complicated angle measure. And so that's what we're going to do right now. There are 6 sum and difference formulas. There is a sum and a difference for sine, a sum and a difference for cosine, and a sum and a difference for tangent. Okay, so let's go ahead and do those right now. We can use a lot of letters, Greek or Latin letters, to represent our two parts of the sum or difference. What we're going to do is we're going to say that theta is equal to A, capital A, plus capital B. So all of these are going to be A plus B or minus. So we're going to say plus or minus, A plus or minus B. So we're going to deal with A plus B or A minus B. So our 6 identities are going to be, the first one is going to be the identity of sine of A plus B, so a sum that makes up an angle. And then we're going to do sine of A minus B. So first we'll do the sum of an angle for sine, then a difference in an angle for sine. Then we'll do cosine of A plus B, and then we'll do the difference. We'll do cosine of A minus B, and then we're going to do tangent of A plus B, and then we'll do the identity for tangent of A minus B. Okay? Now, all right, so the identity, if you have sine of A plus B, that's going to be equal to sine of A times cosine of B plus sine of B times cosine of A. For sine of A minus B, it's pretty much the same, except it's sine of A times cosine of B minus sine of B times cosine of A. Now, do you notice in both of these, they each have both sine and sine and cosine both have a chance at having A and B. We got sine of A here and sine of B over here, cosine of B here and cosine of A over here. They have to be in that order. Has to be in that order. For the subtraction, we definitely have to have these two first, and these two have to be second. Okay. Now, as far as the order, the multiplication doesn't have to be in the same order. You could have cosine of B times sine of A plus if you want to, but I usually put the sine first, simply because it's a sine. It's a sine function over here. All right, cosine of A plus B. This one, it looks very similar to this, but it is there are two distinct differences. The first one is that the first part is cosine of A times cosine of B. So we put both cosines with each other. The other big difference is that when it's plus, when it's a sum in the angle, for cosine it becomes subtraction here. Okay, so cosine of A plus B is cosine of A times cosine of B minus sine of A times sine of B. Okay? And then cosine of A minus B is this exact same thing, only plus instead of minus. it's cosine of A times cosine of B plus sine of A times sine of B, okay? All right, so now we got tangent of A plus B. This one's a little more complicated, but I think you're going to be okay. It's actually a fraction. It's tangent of A plus tangent of B over 1 minus tangent of A times tangent of B, okay? This one's definitely a lot more complicated. Like I said, all you really need to do is memorize it. Write it down 17 times, and it should be stuck in your head. Now, tangent of A minus B looks just like this, only we're going to reverse this plus into a minus, and we're going to reverse this minus into a plus. And so it's going to be tangent of A minus tangent of B over 1 plus tangent of A times tangent of B, okay? And I think what I'm going to do now is, I think I am just going to take one of these and I'm going to show you based on radian angle measures that you already know, just kind of show you that one of these is definitely true. Okay, so let's say that we have a cosine of pi over 6 plus pi over 2, okay? Well, let's go ahead and add pi over 6 plus pi over 2 and see what we're dealing with. We've got pi over 6 plus pi over 2. We need a common denominator. The 6 can stay a 6, but to turn this into over 6, it's going to have to become 3 pi over 6, okay? So we have pi over 6 plus 3 pi over 6. So we've got over 6, and then we've got pi plus 3 pi. That's 4 pi. So what we have here is 4 pi over 6, which can be reduced to 2 pi over 3, okay? So we know that this is the same thing as 2 pi over 3. You might say, well, hey, if you can do that, then why do you even need the identity? Well, we need to be sure that the identity we're dealing with here is going to equal something that we know already, okay? So we know that cosine of 2 pi over 3, so we're going to put this over here, or I'll put it over here. We know that cosine of 2 pi over 3, which is this right here, cosine of 2 pi over 3 is, what do we got, negative 1/2, okay, negative 1/2. So what we're going to do now is we're going to go ahead and plug this pi over 6 and pi over 2 into our pieces here, right? So A is pi over 6, so everywhere we see an A, we're going to put a pi over 6, and B is pi over 2, so everywhere we see a B, we're going to put a pi over 2, okay? So this is going to be equal to cosine of A, which is going to be cosine of pi over 6, right, times cosine of B, which is pi over 2, minus sine of A, so it'll be sine of, and A in this case is pi over 6, okay, times sine of B, which in this case is pi over 2. And now all we got to do, since we know these values from the unit circle, because we know the unit circle, we shouldn't have a problem with this. So now it's going to be equal to, well, cosine of pi over 6, well, that's square root of 3 over 2. Okay? Cosine of pi over 2, look at your unit circle, that equals 0. Minus, okay, sine of pi over 6, well, that equals 1/2, times sine of pi over 2, well, that equals 1. There we go. Square root of 3 over 2 times 0, well, that equals 0. Minus 1/2 times 1, that equals 1/2. And 0 minus 1/2 is negative 1/2. And sure enough, this is equal to negative 1/2. Cosine of 2 pi over 3 is equal to negative 1/2. Therefore, I'm just showing you that this identity really will result in you getting the exact same value on this side and on this side. But typically when we use these identities, it's not for calculating values, because we can calculate values with a calculator. It's for handling proofs and solving algebraic equations, okay? All right, so that's it for the sum and difference formulas. What I would recommend that you do right now is, these are pretty tough, they're lengthy. So what I would do right now is, don't move on to the next video yet. why don't you write these 6 formulas down and then set them aside, write them down again. Keep writing them down until you can get them all from memory so that you don't even have to look. After you've done that, after you've memorized these, go back and do the negative angles and then the sum and difference angles. Then do the cofunction, the negative angles and the sum and difference. Then do the Pythagorean, the cofunction, negative angle, sum and difference. And then after you've done that, do all 5 of these: basic, Pythagorean, cofunction, negative angle, sum and difference. The more that you do these in order, or the more they'll stick in your brain. Now we only have one set of identities that we're going to do. We're going to put them down here, and those are what we call the double angle formulas.